Good morning, students. In the last class, I took the example of unity feedback system given by GSHS equals K over S into S plus 6. K into S over S, K over S into S plus 6. Now, having drawn the root locus for this problem, I want to draw your attention to make a very important observations in this diagram. These observations are one by one. First, if you look into this diagram, it looks symmetrical, is it not? See, it is one branch. This is what is called as one branch. This is what is called as branch number 2. So root locus will have branches like this. Now the very first observation is symmetrical. The very first observation is symmetrical. Symmetrical about axis. Symmetrical. This is very important. If you draw the root locus at the end, if the graph is not symmetrical, then something wrong. Symmetrical. First, this is symmetrical. Next, how many branches here? This is one branch, this is another branch. Always in root locus, number of branches is equal to number of poles of open loop transfer function. So in control system, there are two types of transfer functions. One is called as closed loop transfer function, that is CS by RS. Whereas GSHS is what is called as open loop transfer function. I am not going into the details of this. You know that GSHS is what is called as open loop transfer function. Open loop transfer function. So open loop transfer function. So you can conclude how many branches will be there in the root locus. The number of branches is always equal to the number of poles of open loop transfer function. So here poles, what do you mean by poles? Poles means the roots of the denominator. There are two roots, s equal to 0, s equal to minus 6. As there are two poles, the number of branches here in the root locus is always equal to the number of poles of open loop transfer function. This is second observation. First one is symmetrical. Next, second one is number of branches. Next, where do they originate? See, first branch is originating at origin with k equal to 0. Another branch is originating at minus 6, k equal to 0. Therefore, in root locus, always branches originate at the poles of GSHS, with k equal to 0. With k equal to 0. Branches originate at the poles of GSHS with k equal to 0. Next, that is why they are originate here and here. Where do they terminate? In this problem, there are no s factors in the numerator. That is why they are terminating at infinity. So root locus, they terminate either at the zeros of GSHS. You know what are zeros? Zeros means the roots of the numerator. But in this example, there are no roots, there are no s terms in the numerator. Therefore, they originate at infinity. Therefore, root locus branches terminate either at infinity or at poles of or at zeros of GSHS. That is why they are proceeding towards infinity. This is another observation. And with k equal to infinity. Another extreme value of k is infinity. And one next observation. Next observation is these two are meeting and they are separating. There must be some significance for this point. This point later we are going to call it as breakaway point. breakaway point. Breakaway point. What do you mean by breakaway point? Breakaway point means the branches they meet and they separate. So breakaway point. Therefore S equal to minus 3. Minus 3 is what is called as breakaway point. And next, at what angle it is approaching infinity? At an angle 90 degrees. This is 90 degrees. This is minus 90 degrees. This is minus 90 degrees. And later we are going to call these two angles, plus 90 degree as minus 90 degree, as angle of departure. Angle of departure. So these are the points which are highlighted here. I hope that you have made observation in this diagram, and in the next class I can take up easily what is known as the theory of root locus. Thank you.